So today we are going to learn how we can sort an array. So there are three types of algorithm to sort any array. So in this video we will learn these three algorithms. First one is bubble sort, and second is selection sort, and the third is insertion sort. So these are the basics algorithm to solve any to sort any array. And so first I will explain the algorithm of selection sort, how it works and how it sorts the array. First of all, in this sorting algorithm, we runs two loops. If I talk about the context, so first we select an element from the array. So from the starting, I will select 12. So I selected 12 element. Now I will compare this 12 element with each element that are the those are next element in the array. So now first here, um, 12 I will now here I will compare 12 with 11. So in this 11, the 12 is greater than 11. So what the next so what will happen here, the algorithm will swap the value of 12 with 11, and 11 will come here, and 12 come here. Now now the our second index that was pointing here in the in first index, now it will increase by 1, and it will point it to the next index value. Now currently the second index is pointing to the 13, and here we again compare 11 with 13. So if our compare element is greater than the 13, then we will swap the value of this. Now for but here the 13 is greater than 12, so here we do not need to swap the value. Now the index value will uh, that is the next index there, we were pointing, it will increase by 1, and it will uh, now start pointing to the third index, and the value is 5. So now again here we will compare the 12 with the 5. If it is true, then we will swap, but it is not, but it is, because 5 is smaller than 12. So now the next index value will be, now the 12 and 5 will be a swap. So what is the new array? So here 5 will come here, 11 as it is, 13 as it is, and in the place of 5, here we will place 12 and 6. So this is our new array. Now still we are comparing 5, comparing 5, and our the index that were pointing here to the 5, where I just replaced the value with 12. Now it will point to the next index, which means the next position. Then uh, it will check again, is 5 is greater than 6, then the condition will be false, and here we do not need to swapping the value. So now in the next iteration, what will happen, we will uh, we will compare the next element, mean select another element which is currently where was what we were doing, we were selected the fifth element, we were selected the first element. Now I will now the the value will be the index value of outer loop will be increased by 1, and it will be and it will start it pointing from here, because the second indices or the index value, that is index that is pointing here, that will be increased by 1, and it will point to the out of the array, and the next iteration will be start again, and the outer loop index value will be increased by 1. So the selected element is 11, mean index value which is 1 will start from here. So now here we will check, again 11 is greater than 13, but it is not, so it the index value will again move to by 1, and it will point from here, and it is again here, it is not pointing the value which is greater than. So here it will not, again condition will be true, and it will start, and now it will point here the second index, and it will check again that is 11 greater than 6. Obviously it is greater than 6. Then it will swap the value, and the new array will become like here the 13, 6, 6, 11. So now new array is 6, 13, 12, and 11. So the last we were pointing, we were selected this element. Now in this next iteration we will select this element, and will start comparing this selected element with its next elements. So we will compare one by one. So 13 is greater than 12, so it will swap, the condition will be um, true, and it will in the position of 13, and the position of 13 the 12 will come, and the position of 12 the 13 will come. And this is how now we will compare 12 with 11, and the check is 12 is greater than 11, so the condition is true, and the new value will be 11 in the place of 12, and in the place of 11 the new value will be 12. So our new index, new array 5, 6, 11, 13, and 12. So we were we were selected the element in the third position. Now we will start now in the next iteration we will select next element. So we selected this element. Now we'll start comparing this selected element with its next element in the array. So we'll start comparing with from here, and check is 13 is greater than 12, so it is, and so it will be replaced by 13, 12, and 12 with the 13, and the new array will become, because the it will point outside from here, so it means that that is comparing element index is a position will be uh, out of array, and then the iteration will end, our new array will look like 5, 6, 11, 12, and 13. So this is sorted now. 5, 6, 11, 12, 13. So this is selected element. Now, so this selection sort algorithm we can write uh, in programming. So I am writing the algorithm in pseudocode, so you can convert in your specific language, whatever you are using, Java, C++, C, and whatever you use, you can convert it. So I am going to write the pseudocode of this algorithm. So uh, here you will have an array that can be the size of an n, right? And you will create from I0 to n minus 1, and in this outer loop the another loop will start from I plus 1, because uh, or n minus 1, because we need to check, we need to only compare the next element of the selected element. So ith position of in the ith position in the array, which is targeting, which is the selected element in the array, and the inner loop is j equal I plus 1, which is pointing the comparing elements in the array. So in the inner loop, uh, uh, we will compare array of I if greater than array of j, then it means our targeted element is greater than the comparable element. Mean this is not sorted, so uh, we have to swap. So now we will take t temp variable and store one of them value in it. So currently ai, the index value, ith value, and in the ith position insert the ith jth value, and in the jth position insert temporary value. So this is the pseudocode of selection sort algorithm to sort any array. Here is the code of selection sort in C++. You can convert, I gave you the explanation of pseudocode, so you can write in your language. Here if I run this program, selection sort, here we are getting 5, 6, 11, 12, 13, which is sorted now, and here you can implement the selection sort. The next algorithm is bubble sort algorithm. So in this algorithm, we compare two values before, but we compare just neighbor value, like 12 is greater than 11. If it is 2, then we will just swap to uh, 11, and we just swap 12 to 11, and 11 to 12. So this is how we compare the algorithm. But in this bubble sort, in the each iteration the greatest value will go to the end, in the end. So here we can write, uh, we can we in each iteration we can uh, reduce the number of iteration of inner loop. For example, uh, if we compare I and 11, 12 and 11, then yes, 11 is great is sorry 12 is greater than 11. So what we will do, swap the value with 11, 12, there is 13, 5 and 6. Now in the next we will compare these two value, 12 and 13. Then if 12 is greater than 13, then we will just swap, but here it is not. And then now we will check 13 and 5. So yes, it is 13 is greater than 5. So in this here we will swap the 13 with 5 and 5 with 30. The new array will become 12, 5, 13 and 6. And now we will compare 13 and 6, and it is greater 13 is greater than 6. And here we will again swap the value 13 with 6 and 6 with 13. Now here you can see the bigger value, uh, the most bigger value is came at the end of the array. Now in the second iteration, again we will check from 11 to 13. So 11 and 12 check. So here 11 is smaller than 12. So either here the condition will be false. Then there is no need to swap the value. But in 12 and 5 case, the 12 is greater than 5. Then here we need to swap the value to what we will do. Swap the 12 with the 5 and 5 with 12. The new array will become 11, 5, 12 and 6 and 13. And now we will check 12 and 6. Now obviously 12 is greater than 6. Now we will swap these both of value 6 with 12 and 12 with 6. The new array will become 11, 5, 6, 12 and 13, right? But here you can see 12 and 13 is 12 is not greater than 13. So here we do not need to swap the value. And here you can see again, so here you can see that 12, the most great the most the last most greatest the last second most greatest value will come in the end before just 13. So in the next iteration, again we will perform the same operation on 11 and 5. If 11 is greater than 5, so we will save the value. And in the place of 11 in the place of 11 I will put 5, and in the place of 5 I will put 11. And the 5 is here, and the new array will become 5, 11, 6, 12 and 13. And in the next iteration, uh, we will compare 11 and 6. Yes, it is the 11 is greater than 11 is greater than 6. So here we need to set the value. So yeah, in the place of 11, in the 6 of 6 position, the 11 will come here, and the next and the new array will become 5, 6, 11, 12, 13. And here the our array is now sorted. But in each iteration you can see the one pattern, which is in each iteration the most greatest value is coming in the end. Here you can see, and in the next iteration the 12 here come just before the 13, and the 11 here come just before the 12. So so what will be the pseudocode of this algorithm? We will start from I n minus 1 to 0, and in each iteration we will decrease the value of I. And the inner loop will start from j equals 0 and will run I minus 1. And here in each iteration we will check if array of j is greater than array of j plus 1, then just set the value. Take the temporary variable and store any of variable into temp, and just put another value j plus 1 into j, and in j plus 1 put the temporary. There are only 3 lines of code to implement the bubble sort algorithm, and with this algorithm you can sort your any array. This is bubble sort implemented in C++, and the output of bubble sort is also sorted now with the help of a bubble sort algorithm. And I gave you the explanation of uh, algorithm in pseudocode, so you can convert in your language. Next algorithm is insertion sort, in which we compare in which we in the initial time we assume that the first element is already sorted, and we compare the it unsort we take one element from the unsorted array and compare in the sorted array from the last index to check that is 13 is the last index of the sorted array is greater than to the current selected element from the unsorted array. If it is, then we just place the value from 13 in the place of 13 11 in the place of 11 13. So the visual representation of this insertion sort, which is, as we know, we took this element as in the first element as sorted array. So what will happen here? So here we take 11 as the element to check from the last index of last value of the sorted array. So I will check here is 13 is greater than 11. So yes, it is. And so what we will do, we just swap the value with 13. So new array will become 11 and 13. And then in the next iteration, 13 12 5 6. Here you know that this part is sorted, and in the unsort and from the unsorted elements from the array we took 12, and again we will start comparing the elements from the sorted array from the last index from the sorted array. So we will compare 13 is greater than 12. So yes, then what we will do, just swap the 12 with the 13, and now again we will check that is 11 greater than 12. So no, the mean, because it is sorted also, so we do not need to go more to check because the sorted array is already sorted. So from this point the all elements from the left side is always smaller than 12. So in the new sorted array will become 11 12 13 and 5 and 6. In this point we know that this part is sorted now, and from the unsorted array we take element 5. Now we'll start comparing with from the and we'll start comparing from the array from the sorted array, and in the from the last index of the sorted array. So we will check is 13 is greater than 5. So it is. it is smaller than 5, so what we will do, just 5 and 13 will come here, right? And again, uh, we will check is 12 is greater than 5, so it is, and we will just swap the value 12 with 5 and 5 with 12. And again, uh, it will check is 11 greater than 5, so it is, and we will just swap the value 11 with 5 and 5 with 11, and the new array is 5, 11, 12 and 13 and 6. Here we know that this part here we know that this part is sorted now, and we have this unsorted part, and we take element 6 from the unsorted part and will start comparing from the last value of sorted array. So again we will check 13 is greater than 6, 12 is greater than 6, 11 is greater than 6, and till then it will stop here, and when it will come here 5 is greater than 6, it will be false, and the uh, iteration and the code will stop here, and the new index will become 5, 11, 5, 6, 6, 11, 12 and 13, and this is sorted now. So this is how you can sort. This is the approach and visual representation of insertion sort, how it works, and how it take the element, and how it compares the each element from the sorted array, and how it insert and swap the elements of each uh, elements from the array. So now the pseudocode of this insertion sort, which is, we will take I that will start from 0 and will go to n minus 1, and here we take j and assign I, and we run one while loop under the outer loop if, and assign a one condition, which is j should be greater than 0 and a of j minus 1 greater than a of j. It means we need to swap the value, so we take any temporary variable and store a j minus 1 into it, and and in j minus 1 of array store the j, and in the j the position of array at the temporary variable that you stored that, and this will come under the if element. And no, it is correct because we are already checking with while loop, so here we do not need to write any if else. uh, this is a, so what is happening here, and in the last we will decrease the value of j because we are comparing from the last index of the sorted array to the 0. So this is how you can sort your you can implement the insertion sort on any unsorted array. This is the insertion sort, and the algorithm is implemented in the C++ language, and I give you the explanation of pseudocode of each algorithm so you can convert those pseudocode algorithm in your language, whatever you are in which you are comfortable. And here you can see all of them algorithm are working correctly, so you can implement these sorting algorithm on any array to sort them.